Alright, apes, kiddos, since we're having some problem with feedback loop, let's talk a little bit more about it. Remember, a feedback loop, essentially, we talked about outputs and inputs. So the idea behind a feedback loop, and I think the part that we're missing, is that the output, okay, of the loop has to feed back into the input and cause some sort of change in it. Okay, that is the essential gist of a feedback loop. It's not just a cause-effect relationship, as a lot of the stuff that we try to do in class was. It is that whatever the output is goes back into the input and affects it in either a positive or negative way. So let's look at a quick example of a positive feedback, and this is a good environmental example. So let's say that we've got a river, okay, or a dam or something like that set up, and then the vegetation in it starts to decrease, maybe because the water flow has been stopped. And so the decreasing vegetation causes the vegetation was originally holding the soil in, and so the soil starts to erode. The nutrients then become less, and so more and more vegetation then starts to die. This is a positive feedback because the original input was the decreasing vegetation. And so as the soil begins to erode and we get less nutrients, then more and more of the vegetation is starting to die. The original input, okay, is increasing. Okay? The loss of vegetation was the original input, and as the nutrients pull away, then that's more and more decreasing vegetation, okay, more and more loss of the vegetation. So that's a positive feedback. And again, remember, positive and negative don't have any ethical or moral judgments on them. They just mean that the effect they have on the system. So if the system was initially decreasing, as in this case, then a positive feedback would be more decrease, okay? A good classic example of a negative feedback, or sometimes called a corrective feedback, is that it makes the system go in the opposite direction, okay? So a good example of that is the thermostat. So you set your thermostat, you want your house to heat up, it's the winter time, and so the furnace kicks on, it heats up to whatever setting you have, on this example here, 70 degrees, and so when that happens, it cuts the furnace off, the furnace gets cut off, and then the house is going to start to cool, okay? And as the house cools, then the thermostat, the temperature goes down, and so the thermostat says, hey, it's supposed to be 70 degrees in here, so it kicks the furnace back on, okay? So negative feedback, because it's basically a corrective thing, we're going back and causing things to kick back on, okay? It's moving in the opposite direction of the original input. The input here basically is that the house is starting to cool, and so the thermostat causes it to kick back on, okay? And again, you'll notice that it's a looping sort of process. Another couple of quick notes. It can take a long time for the feedback effects to become visible. This is particularly true in environmental problems. And in a lot of environmental problems, it takes a long time until any real feedback effects start to happen. So you can start to, say, damage an ecosystem, and initially you don't really see any change, but maybe 10, 20 years down the road, you start to see that change. And I think that vegetation example is a good idea. When you initially cut things, it's not like everything starts to go away right away. It takes a while for the things to erode, but once they do, it tends to happen relatively quickly.